Hello everyone. In part 2 of Unit 5 UGC NET JRF Forensic Science, we will discuss about basics of internal, external and terminal ballistics. So we will start with the mechanism of firing. When firing pin strikes the percussion cap of the cartridge, it produces an indentation in the percussion cap and priming mixture is present inside the percussion cap. So when it gets crushed, priming mixture that is composed of high explosives such as lead stipnate, antimony sulfide and barium nitrate as oxidant, antimony sulfide as fuel. All these combine to form a lot of heat. It produces lot of heat. This heat or this flame will ignite the propellant, that is the low explosive, and the propellant burns and is converted into gases with high temperature and pressure. These gases expand and will propel the projectile. So the projectile will hit the target. So when these gases exit from the muzzle, the gases formed due to the burning of propellant. So when these gases exit from the muzzle, they will contain the vapors of lead, barium and antimony. Lead, barium and antimony were present in the priming mixture. So these lead, barium, antimony vapors will condense into small spheroids, invisible spheroids, and they will get deposited on the hands, face and clothes of shooter or any other object or person near firing range. So these spheroids are also known as gunshot residues. So this GSR will help in uh, the shooter. So after firing, when bullet comes out of the muzzle, there will be hot gases, smoke, unburnt or partially burnt propellant particles that are present behind the bullet that will give a particular trajectory to the bullet. And along with that, there will be tiny chips of lead or copper. This lead or copper will be due to the jacket of the bullet in case of jacketed bullets. So the gases that evolve are carbon monoxide, carbon dioxide, hydrogen, nitrogen oxide and water. So when carbon monoxide and hydrogen combine with the atmospheric oxygen, flame is produced. So you must have seen that after firing, there will be flame generating from the muzzle end. So this flame is different from the flame that is generated during the crushing of priming mixture, and this flame will extend up to 6 inches in long barrel firearms and will be up to 2 to 3 inches in case of pistols and revolvers. And if the target is very close to the firearm or it is within the range of the flame, that is 6 inches or 2 to 3 inches, then this flame and hot gases will produce burning, scorching, charring, singeing effects. So singeing of hair is similar to burning. In case of hair, we'll call it singeing, as it will curl down. Along with the flame, smoke is also present. So the smoke consisting of carbon particles, it will travel up to 12 inches in case of long barrel firearms and 6 to 8 inches in case of handguns. So this deposit of smoke on the target will be known as blackening, and the unburnt and partially burnt propellant particles will travel up to 4 feet in case of long firearm and up to 1 to 2 feet in case of handguns. So these deposits will be known as tattooing or peppering. So all these deposition will help us in identifying the whether the wound is entry wound or the exit wound, and what will be the possible range of the firearm to the target. What will happen when bullet enters the body? So when the bullet enters the body, the skin gets stretched, and there will be an abrasion around the entry. This abrasion around the entrance hole is known as abrasion collar. There is another type of ring that is formed, that is known as dirt ring, around the entrance hole due to the deposition of lubricant and dirt on the bullet when it passes through the barrel. The elements of bullet, lead or copper, also get deposited on the entrance hole to form lead or copper ring. So there will be four types of ring: abrasion ring, dirt ring, lead or copper ring around the entrance wound, entrance hole. So the mechanism of firing will be related to internal ballistics. After firing will be related to intermediate ballistics, and when the bullet enters the body it will be terminal, or if in case of human beings it will be wound ballistics. The resistance acting on the bullet. So when the bullet is moving in air or body, the resistance will be calculated by the formula half rho a square v square c d, where rho is the density of the medium in which the bullet is moving. In water, the density of the medium is 800 times more denser than the air. A is the area of cross section of bullet, V is the velocity of bullet, and C and D are drag coefficient. When the resistance is more, the damage will be more. Ballistics coefficient or coefficient of reduction. It is the measure of its ability to overcome air resistance in flight. So ballistics coefficient is given by the formula BC is equals to W by ID square, where BC is the ballistics coefficient, W is the weight of the projectile in pounds, I is the dimensionless shape, it is the shape factor, D is the diameter of projectile in inches. If the ballistics coefficient is more, then the ability to overcome air resistance is more. Now another formula, Hatcher's formula for relative stopping power or RSP, it is equals to m by 2gAf, where m is the momentum of the bullet in foot or pounds per second, and g is the acceleration due to gravity in feet per second square, a is the frontal area of the bullet in square inches, and F is a bullet form factor that varies depending on the type of the bullet. Now, net retardation of a projectile due to air resistance is given by the formula AVN, where A and N are the constants and V is the velocity of the projectile. So these were the various formulas. Thank you for watching. Stay tuned for more such videos. Thank you.